this video on simulation. By the end of this video, you should be able to use simulation to model a random process in order to estimate a probability. So the scenario we're going to do this in today is our soda contest true. Pepsi ran a promo contest for their 20-ounce bottle of soda. Some of the caps said, "Please try again," while others said, "You're a winner." Pepsi advertised the promotion with the slogan, "1 in 6 wins a prize." Our statistics class wonders if the company's claim is true. So to find out, 30 of the students go to the store and each buys a 20-ounce bottle of soda. 2 of the students get caps that say, "You are a winner." So if there are 30 students in the class, how many of them would you expect to win a prize? If it's the probability of winning is 1 in 6, so if we had 1 out of 6 out of the 30, we would expect there to be 5 winners. So we didn't have 5 winners, which makes us curious. Is this a fair contest? So we would expect these 5 winners, but it really isn't guaranteed. It just says 1 in 6 wins. That means they're making 1 in 6 bottles as a winner, but that doesn't mean you're going to get the 1 in 6 bottles. So it's not guaranteed, but we still are questioning. So we're going to perform a simulation. We want to know, does this result give us convincing evidence of the company's 1 in 6 claim is inaccurate? So for our simulation, we are going to use a die, because our probability of winning is 1 in 6. A die has 6 sides, each with a different number, so it's a perfect randomness item to use. So we're going to roll a die. So we're going to assign certain outcomes to losers and winners. That way we know if what shows up is a winner or not. I'm going to say if you roll a 1, that's going to be considered a winner. You could have picked any number. And if you roll any of the numbers 2 through 6, you're going to be a loser in this scenario. Alright, so what we had the classes do is we had them roll the dice 30 times and count how many ones they got in the 30 times. So I did this one time through and I got a 5 winners the first time through, and when I repeated it the second time through, I got 2 winners out of the 30 rolls. So the 30 rolls represents each person in the class. You're simulating an entire class. So then I had the class plot their dot plot. So let me show that to you so you can copy it down. So here's the results of our collection of our data this morning, our simulation. We had this distribution. I went ahead and put the numbers at the top so you know how many dots that you can put. Go ahead and pause the video so you can get this written down, copied down, so we can continue on. Alright, now that you've copied this down, let's take a look at what % of the time did the statistics class get 2 or fewer prizes just by chance. So 2 or fewer. So all of these right here, because remember we're always wanting to know the probability is being as extreme or further than the results that are being claimed. So we got 4, 5, 6, 7 out of 10. So 7, and then when you count them all up, we had a total of 54 simulations that we ran. So 7 out of 54 is 13%. So does this seem plausible that the company is telling the truth, or did just the one class get unlucky? Do we have convincing evidence that Pepsi is lying? So we do not have convincing evidence. This is more than 5%. So not convincing evidence that Pepsi is lying. Because we have a 13% chance of those results just purely by chance. So because we have a 13% probability of getting 2 or fewer winners purely by chance. Okay, so we didn't prove anything. We just made an example situation that mimicked what Pepsi was claiming, and we found that in those 54 trials, we had two or fewer winners 13% of the time. Not unusual. Remember, it would be unusual if it was less than 5%. All right, let's summarize what I want you to know for today. All right, the first thing I want you to take away from today's lesson is the idea of a simulation. A simulation is an imitation of a chance behavior based on the model that accurately reflects the situation. You can use dice like we did today, you can flip a coin, you can use an applet, or you can use a random number generator. We've actually done multiple simulations throughout this course, including day 1 when we did Joy smelling Parkinson's disease. So simulation is just an imitation of what's going on, so you get an idea, so you have some data that you can work with. The other thing that I want you to know about is the simulation process. These are the 3 things that I'd like you to do to consider and make sure you mention when writing out what your simulation process is. You need to describe how you will simulate one trial or one repetition. So that tells me if you're doing the dice like we did. You have to tell me which numbers are winners and which numbers are losers. I have to be able to replicate what you're doing. Then you need to perform many trials. And then finally, you need to use the results to answer the question. So what I'd like you to do is try the check your understanding. Go ahead and try part A and part B, and then come back and we'll see how you did, and then we'll do part C together. So in part A here, if we were following the 3 steps for the simulation process, the first thing you need to be able to do is describe how you will simulate. So I said, and you could have said something different, but I said I was going to use a random number generator. And I'm going to use my low number as 1, my high number is 9. Because there is a 1 in 9 probability of getting a bankrupt here to get 50 integers. Now, which is a winner and which is a loser? I said let 1 equal bankrupt, and then 2 through 9 are other outcomes. So I use my random number generator. I'm generating numbers 1 through 9. 1 is going to be bankrupt. Everything else is okay. That's just a different outcome. And then our second step says perform many trials. So I would say do this many times. So do this many times, that's really your second step. And then the third part is use the results to answer the question. So we're going to estimate the probability of 10 or more bankrupts, because that's what our scenario was talking about. All right, so we had all 3 parts. I said how I was going to randomize. I said who's a winner and who's not. Do this many times, and then what do I do with the results? I'm going to estimate the probability of 10 plus bankrupts, because that's what the scenario was talking about. Then here we have a display of a simulation. The results of 100 simulated trials of 50 spins. Okay, so we have to be able to explain what a single one of these dots means. So this one wants to know above the 12. So the dot above the 12 out here is in one simulation and the simulation was of 50 spins of the wheel, there were 12 bankrupts. All right, so the last question is, what conclusion would you draw about 10 or more bankrupt spins occurring in 50 spins? And then I want you to explain your answer. So in this example, if I go look, 10 or more is right here. So that is 4 out of 100, which is 4%. That's less than 5%. Remember, we were saying that's an unusual amount if it's less than 5%. So when we started this, we were assuming the wheel was fair. You have to assume the wheel is fair. So assuming the wheel is fair, if it's working the way they said it's working, there is only a 4% chance of getting 10 or more bankrupts. All right, because we assumed the wheel was fair, when we did our simulation, there was only a 4% probability of getting 10 plus bankrupts in 50 spins. Because this is unlikely, because it's less than 5%, we have convincing evidence that the wheel is unfair. Because it's less than 5%, something else must be going on. So maybe that something is somebody tampered with the wheel. It's unfair. It's not working the way they said it was going to work. Hopefully that was helpful. Let me know if you have any questions. See you in class.